Let us start with second law of thermodynamics. What second law of thermodynamics? Before that, I wish you happy New Year.
Thank you so much.
Yeah. So because I am sure this year makes you right a wonderful year, it fulfill all your dreams, and I wish you to be strong for all your plus and minuses, and be right. Don't bother of situation. Handle carefully and keep moving. Okay, good. So second law of thermodynamics. See, on this year, I'm studying new law. Second law of thermodynamics. See, we must be just like a second law of thermodynamics. We must be just like a second law of thermodynamics. What second law of thermodynamics says? It says that simple. All the process happens in the nature in one direction. All the process in the nature, you can say anything happens in one direction. Let's go. Heat flow from high temperature to low temperature. Right? Water falls from where? What happens? High to low. When high from larger height to low, right? And take anything that's it goes only one direction. I did give examples here. Heat flow, high to temperature, water falls. Okay, water falls from high to low. Right? All the process it happens by nature in one direction. First law says you can convert work to heat, heat to work, but it does not deal with the direction. Second law says that it deals with the direction of energy transfer, in which direction energy transfers, and it also deals with even a reverse also possible. How? Heat flow, okay, all natural processes, naturally, heat flow comes from where? High temperature, low temperature. We know. For example, I brought a cup of tea. That cup of tea in a hole, right? So, after 10 minutes, 20 minutes, the temperature is it transfer from the cup of tea to the surrounding. Okay, so it's natural process, but reverse possible? Possible. That is second law of thermodynamics says it is also possible. How possible? Simple. We can transform. Same. I told. We done right? Refrigerator.
Yes, sir.
Very good. Imagine the refrigerator. So what happens? This is a fridge area which is called cabin temperature. Cabin. This is kitchen. What do you do, ma? Why fridge required? Fridge required to maintain the temperature of cabin lower than atmosphere. Sure. So how can you maintain? By supplying additional work. Happened or not? What happened? Here heat transferring from low temperature sink to high temperature reservoir. Happened or not?
Yes, sir.
How it happened? It was possible by adding additional work. Make sure. Sorry. Make sure everything is possible, but it requires some additional skills, additional work. We know, right? The difference between an ordinary and extraordinary person. What ordinary extraordinary person? Ordinary person they do ordinary things in ordinary way. But extraordinary things, they do same things in some extra way. Right? They do the extra. They do extra. So they are extraordinary. Right?
You are telling it's natural.
Naturally from high to low. Naturally from high. That's why you have heat engines. That's why you have a heat engine. What heat engine says? Exact opposite. Heat engine what happens? Heat engine takes heat from a source. Okay. And produces work and rejects heat to the sink. Correct? No? It happens naturally? Yes or no?
Naturally, sir.
Yeah, naturally is one direction. For example, a cup of tea. Okay, this happens naturally. Anything extra required? No. Burning fuel, running engine, okay, rejecting heat to solution. That's it. It happens naturally. Really point? So here what happens? Okay, to run refrigerator, it needs electricity. If you have current, it runs. If no current, I can use fridge as an almara. I can keep my cloth, I can keep my watch, I can keep all the things. Very simple. And even at heat flows at high temperature, even to a cup of tea. When kept it goes, okay, heat added to something surrounding immediately. Then both become same temperature. Cup of tea and atmosphere. Heat flow from high to low. Reverse possible. Yes or no? Heat transfer from low to high. That's why refrigerator. And here, compared to waterfalls. When you go to Joe Falls, we say, wow, how wonderfully waterfall, right? Raja, Rani, Rodo, Rocket, super. We enjoy. Yeah. You never thought we do reverse also? Reverse possible or not?
No, sir.
From waterfalls from high level, okay, higher level to low level. Possible or not?
High to low. From top to bottom it is possible.
Yes, waterfalls. Okay, but reverse possible?
No, sir.
Possible, ma. We can do anything. Never ever say impossible. It is possible.
But we need to apply some work, sir.
That's why I told, right? That's why the simple thing, we get extra thing you have to do to be extraordinary. Same thing right here. Heat, refrigerator, what doing? Fridge works. Yeah, fridge. Well, very good. You have fridge. Everything we bought for your house. If there's no electric supply means, even current connection, fridge and train agutadu. Almara agutadu, right? Almara tagottu fridge agutadu. So make sure to before bringing a fridge, okay, refrigerator, we have electric supply. I have a special plug, 3H plug, three-phase plug, or anything, earthing. What to do? TV tarde manega, nimane current bill TV something model. Correct, simple thing. So we could work. Similarly, I can, okay, we can do reverse water falling on top to bottom. Reverse also possible by using a special device called. Wow, pump man, carrying the pump. And the way, we know right pump if water plan, reverse possible. But how see, I'm going to pump it again. We never ever say when we switch and pump. Wow, pumping water. Great. We never say, right? So why? This is became for simple thing. We never ever recognize it. So, but this also happens. How pump runs? Electricity. Same thing. Reverse also possible by adding extra work. This will last class we discuss about refrigerator and one more heat pump. Both require inputs, extra work. Then when they work, they do some work. Else they won't do. Clear? This is about second law of thermodynamics. And here, second I introduces a special term called entropy. ENTR, okay? Entropy. Zero time makes introduces temperature equilibrium, thermal equilibrium. First line introduces internal energy. Second line introduces entropy. So E, triple E, remember. Okay? So entropy. What entropy? First of all, I'll tell you. Finish this, I'll tell you about entropy. Entropy is a beautiful concept. Entropy andre ಏನು? See. Entropy is nothing but the images. Images explains more than words, correct? Entropy. What is this? Wall. Okay. So can you see bricks right arranged? And sure. What happened? Same bricks. What difference here?
They are arranged in order, they are not arranged.
So that means here disorder less, Here, more disorder. Correct?
Yes, sir.
And then, means, entropy means the randomness of a system. Is it what you call? It is called a randomness of the system. So random ಅಂದ್ರೆ ಏನು? Random means, see, we do March 1st, we do during Republic Day, coming Republic Day, or we do right with okay, our Independence Day, we do Republic Day, okay, March. They do March 1st exactly unique and same path, everything. It is called, okay, with a less entropy. There are orders, right? Order way. And during that time, if you give any orders, they fall immediately without, okay, what you call disturbance. But when we gone to the theater, when the movie release, movie done, movie completed, when you want the theater, I watch movie, then after movie ends, how they comes public?
Crowded.
Yeah, they come in a crowded. You tell, hey, wait, I want to have an announcement. Anyone listens to you? No. So that is entropy. In mob, entropy is more. In a march first, entropy is less. In a parade, okay, entropy is less. This is entropy, random system. So, lesser the entropy, more the work we can extract from the system. I repeat, lesser entropy, we can get extract more work. More entropy, okay, more loss there only. Forget to adjust internally itself. That's why entropy of the system must be lower as possible. And this entropy we decide by a simple factor that is called, there are two processes, very important co-process, reversible and one more process. Yes. Andre reversible, the process can be reversed. And here entropy is almost null, no disturbance, no randomness, nothing. Very simple. Reversible process. I mean, I can come back to initial position. When I start from, okay, for example, if I start from A, I can go to B, and even I can come back from B to A without changing system and surrounding. What about here? Irreversible. I can go to A, but never come back. I can come back. If I come back, it's too difficult. There's a lot of changes in the system surrounding. First I go irreversible. Example. For example, I have your paper. Okay. I ask you to please burn this paper. If you burn this paper, okay, you got ash. Can I do reverse?
No, sir.
If cool ash, if freeze ash, I get paper.
No, sir.
No. It is irreversible process. It is irreversible. Burning of paper. First example. Burning of paper. Next. One more take. Heat transfer. One heat transfer. Cup of tea. A cup of tea. Hot cup of, okay, with the hot tea. I kept it now in the room, classroom. After some time, it cools. Heat transfer to surrounding. Can we make it reverse?
No, sir.
Okay, we can't make it reverse. Heat transfer is in one direction. Irreversible process. Any point?
But we can heat it, no, sir.
Perfect. We can heat it, not in the cup. Again, I'll take it to the, okay, and kettle and heat it. It's not reversible. This is change system. Here I am considering cup of tea and this surrounding as a system. ಏನು ಮಾಡಿ ಇಲ್ಲೇ ಮಾಡೋದು ಹೊರಗೆ ಮಾಡೋಂಗಿಲ್ಲ ಮತ್ತು ತೊಗೊಂಡೋಗಿಲ್ಲ ಎಕ್ಸಾಮ್ ಅಲ್ಲೇ ಬರಬೇಕು ಮನೆಗೆ ಬರ್ತೇನೆ ನನಗಿಲ್ಲ ಕರೆಕ್ಟ್ ಯಾರು ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮ್ ಮೀನ್ಸ್ 3 hours sleep, you are right. Someone says, no sir, today I am not feeling well, I'll go to home and I'll write tomorrow.
No, sir.
No, right? So same as that. Clear? If you have any normal, okay, in your house you can do. And, okay, this is irreversible. We can't go reverse, only one way direction. Come back to reversible. Wow, something beautiful. Can you reversible process? Any?
Ice to water and water to
Yeah, very good. Melting of ice will do, take. Yes, there was possible, right? Melting of ice. Simple, I can do. And stretching of rubber. Rubber, make sure it don't break. Stretching of rubber. You use a paper, right? You played in class. So rubber. Stretching of rubber. Stretch it and come back. The stretch is come back. So stretching of rubber. Even spring. You know right, one spring we have one. When you go to fun fair, we get spring. When you keep the steps, it comes fast, tuck. But it maintains same length. I can play with it. Spring. So spring the same becomes reversible. I can make reversible possible. No extra is required. No changing system surrounding. Okay. So reversible, irreversible. Two things very important. Reversible process, irreversible. And in nature, very few are reversible. Meaning maximum are irreversible. Okay. Clear?
So here heat. I mean, in the irreversible, heat will transfer. Again will heat and again the tea will become hot. But in reversible, again the heat which is the coldness which is transferred again it won't come back. Means again we should keep in fridge.
Here we can do melting of ice. I can melt and I can freeze because there is no change in mass. One thing, right? So mass changes. Burning a paper, I told. If burn paper enough, even freeze it, squeeze it, what do you do? I can make paper again. And here temperature heat transfer in a finite temperature difference. For example, okay, a cup of tea I told. Cup of tea have a tea may be at 70 degrees Celsius, surrounding 25. After some time, tea won't freeze. It freezes. No, it balances with the surrounding. Around temperature maybe 25 degrees Celsius, so it reduces 70 to 25. Then stops. Again, don't come back. This is called finite temperature difference. And even one more thing, reversible. If you have a cup of tea, there is no sugar. We add sugar, we stir it. It's called diffusion. Again, can you reverse it?
No, sir.
No, I don't want. I sugarless drink. Give me sugarless tea, miss. You have to prepare separate. We can't take sugar from it, right? So one of the processes called diffusion involved. Diffusion also involved. Diffusion, non-reversible. And
digestion.
Very good. Digestion take. And even friction. I am standing here because of friction. Okay? If no friction, I'll slip, obviously. But can I regain it? No. That's it. Friction between moving parts you can take. Irreversible. Okay? I cannot. Till now, not explained second law. I'm just keep going around of it. I'm doing production of temple. Not entered inside the right. The main. Okay, I don't. Is it clear now?
Yes, sir.
Randomness. Okay. So this is about second law. In and out. Not in and out. Okay. Surrounding second law. So now we enter the real thing. In second law, there are two statements. Two scientists. It's a three scientists they give. First we call KP statement. Kelvin Planck statement. I mean very short. Kelvin Planck statement. Second law of thermodynamics. Here the thing. Second law of thermodynamics says Kelvin Planck any device, okay? Any device. It is impossible. And the word called it is impossible to run or impossible to work an engine or any system when it was exchanging heat with a single source and doing work. Possible? This is impossible to do. This is heat engine. Let's say it's an engine. What is this? It is impossible to construct a heat engine operating in a cycle, exchanges heat with only one source and produces work. Sink illa. No sink. Is it possible? This means what? Simple. It takes Q1 amount of heat, produces W. What happens as for this? Efficiency, output by input. What output here? Work. Input is Q1. So input equal output you got, right? Input equal output we know, as for that Q1 equal to W. Then efficiency how much you got? 100%, right? 1 by 1 into 100, how much efficiency? 100. So now tell me, any engine in the world have 100% efficiency? Anyone is 100%? No one is 100%. Even Mr. Perfect of Bollywood, America, not perfect. Last in Chennai movie flop I think. So not about movie, no one is about perfect. We are every moving towards perfection. So possibility illa. So we require a sync. Compulsing ಬೇಕು. This is impossible. This is statement of KP. Any device is impossible to construct a device operating in a cycle, exchange a seat with the only one reservoir and produces work. ಇಲ್ಲಿ ಯಾವುದೂ ಇಲ್ಲ 100% efficiency engine. ಇಡೀ ಪ್ರಪಂಚ ಆಗಲ್ಲ ಎಲ್ಲಿ ಇಲ್ಲ. Maybe only imaginary like Carnot cycle. Carnot cycle, we say Carnot reference, yeah, Carnot. We take the reference cycle. It's having a highest efficiency compared to all. Even Carnot doesn't have 100% efficiency. Carnot okay, ದೇವರಪ್ಪ ದೇವರಾಗಿಲ್ಲ ಒಂದು ದೇವರಪ್ಪ ಎಲ್ಲ ಪವರ್ಫುಲ್ ಸಿಗುತ್ತೆ ದೇವರು ನೆಗೆಟಿವ್ ಇಲ್ಲ ಅಂತೀವಿ ರೈಟ್ ಬಟ್ ಓಕೆ ದಿ ಕಾರ್ನರ್ ಸಿಮಿಲರ್ಲಿ ಲೈಕ್ ಇನ್ ಇಂಜಿನ್ಸ್ ಇಟ್ ಹ್ಯಾವ್ ಹೈಯೆಸ್ಟ್ ಎಫಿಷಿಯನ್ಸಿ ವಿ ಅಸ್ಯೂಮ್ ಅಷ್ಟೇ ಅಸ್ಯೂಮ್ ಮಾಡಬಹುದು ಪಾಸಿಬಲ್ ಐತಿ ದಿಸ್ ಇಸ್ ಕೆಪಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೆಲ್ವಿನ್ ಪ್ಲಾಂಕ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಓಕೆ ಕೆಪಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಸೆಕೆಂಡ್ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ It's impossible. This is called PMM2. PMM2. Killer, right? So here is the PMM. PM killer. So we know PM. Who is the PM? But we don't know PMM2. Andre, perpetual motion of machine kind 2. Perpetual motion of machine kind 2. Perpetual andre. Imagine ಸುಳ್ಳಾಗಿಲ್ಲ ಹಂಗ ಇದು ರಿಲೇ ಇಲ್ಲ ಸುಳ್ಳು ಅಂತೀವಿ ನಮಗೆ ಇದು ಮಾಡಕ್ ಬೇಡ ನನಗೆ ಗೊತ್ತದ ಏನಂತ ಹೇಳ್ತೀವಿ ಸುಳ್ಳು ಇಲ್ಲಿ ಇಂಜಿನ್ ಇಲ್ಲ ಅದಕ್ಕೆ ಇಂಜಿನ್ ಇಲ್ಲ ಇಂಜಿನ್ 2 ಇದೆ ನೀನು ಸ್ವಲ್ಪ 2 ಐದು 1 ಅಂತ ಕೇಳ್ಬೋದು ನೀವು 1 ಇಲ್ಲ 3 ಹೌದಾ 1 ಇಲ್ಲ 3 1 ಇದಕ್ಕೆ ಡೇಂಜರ್ ಇರ್ತದೆ 2 ಬಿಟ್ರೆ PMM 1 ಏನ್ ಗೊತ್ತಾ ಸಿಂಪಲ್ ಅಲ್ಟೆ ಏನು ಅಂದ್ರೆ ಒಂದು ಇಂಜಿನ್ ಆಯ್ತಪ್ಪ ಇದು ಕಂಟಿನ್ಯೂಸ್ ಕೆಲಸ ಮಾಡ್ತದೆ ಇನ್ಪುಟ್ ಇಲ್ಲ ಅದಕ್ಕೆ ಓನ್ಲಿ ಔಟ್ಪುಟ್ ಯಾವ್ದೈತೆ ಕರೆಕ್ಟ್ ಔಟ್ಪುಟ್ ಬರ್ತಿರ್ಬೇಕು ಇನ್ಪುಟ್ ಕೊಡಂಗಿಲ್ಲ ನಾ ಏನು ಕೊಡಂಗಿಲ್ಲ ವರ್ಕ್ ಕೊಡಂಗಿಲ್ಲ ಪೆಟ್ರೋಲ್ಸ್ ಕೊಡಂಗಿಲ್ಲ ನಾ ಏನು ಮಾಡಿ ಊಟ ಹಾಕಂಗಿಲ್ಲ ಏನು ಹಾಕಂಗಿಲ್ಲ ಕೆಲಸ ಮಾಡಿದ್ರೆ ಇವತ್ತು ಸಾಧು ಸಂತರು ಊಟ ಬೇಕು ಜೀವನ ಮಾಡಕ್ಕೆ ಅಟ್ಲೀಸ್ಟ್ ಮಿನಿಮಮ್ ಗಾಳಿನೇ ಬೇಕು ಅವ್ರಿಗೆ ಹೌದಾ ಈ ಗಾಳಿ ನೀರಿಲ್ಲ ಆರಾಮಿಗೆ ಬರ್ತಂದ್ರೆ ಕೆಲಸ ಮಾಡ್ತದೆ ಏನು ಮಾಡಂಗಿಲ್ಲ ಜಸ್ಟ್ ಲೈಕ್ ರಾಕ್ ಅಂಡ್ ಸ್ಟೋನ್ಸ್ ಅವು ಕೆಲಸ ಮಾಡ್ತಾವ ದೇ ಆರ್ ಡೆಡ್ ಸುಮ್ಮನೆ ಇರ್ತಾವ ಏನು ಒತ್ತಡ ಉಸ್ಕೊಳ್ತಾವ ಎತ್ತು ಬಿಸಾಗಿ ಬೀಳ್ತಾವ ಏನು ಒಟ್ಟ ನೋಡಿದ್ರೆ ಯಾಕೆ ಹೋಗ್ತೀನಿ ರೋಡ್ ಬಾಗ ಕಲ್ ಬರ್ತೀನಿ ನೋಡಿ ರೋಡ್ ಬಾಗಾದ್ರೆ ಹೋಗೋದು ನನಗೆ ಹಿಂಗೆ ರೋಡ್ ಬಾಗ ಕಲ್ಕಂದ್ರೆ ಈಗ ಜಾಸ್ತಿ ಸಂದರ್ಸಿದಲ್ಲ ಹೋಗ್ತದೆ ಇವನ್ ಕಲ್ ವಾಪಸ್ ಬಂದ್ರೆ ಯಾಕೆ ಹೋಗ್ತೀರಿ ಏನು ತಗೊಂಡು ಕೇಳ್ತದೆ ಇಲ್ಲ ಇಟ್ಸ್ ಡೆಡ್ ಬಟ್ ಏನೇಳ್ತೀನಿ PMM 1 ಅಂದ್ರೆ ಆ ಡಿವೈಸ್ ಇಂಜಿನ್ ಓಕೆ ಇಟ್ ವರ್ಕ್ಸ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಇನ್ಪುಟ್ಟೇ ಕೊಡಂಗಿಲ್ಲ ಏನು ಕೊಡಂಗಿಲ್ಲ ಐತೆ ಯಾವ್ದಾದ್ರು ಇದರಲ್ಲಿ ತೊಂಬರ ಫಸ್ಟ್ ಯಾವುದಿಲ್ಲ PMM 1 ಕ್ಲಿಯರ್ ದಿಸ್ PMM 1 ಇದು ಇದಕ್ಕೆ ಎಷ್ಟಾಗುತ್ತೆ ಇದಕ್ಕೆ ಬಾಲ ಐತೆ ಇದಕ್ಕೆ ಬಾಲ ಮತ್ತು ಮುಖ ಎರಡದು ಆದ್ರೂ ಕೆಲಸ ಮಾಡಂಗಿಲ್ಲ ಕೈ ಕಾಲು ಬೇಕೇ ಬೇಡ ಮತ್ತೆ ಕ್ಲಿಯರ್ ದಿಸ್ ಇಸ್ KP ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೋಪ್ ನೋಡೋದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಬೇಕಾ It is impossible to construct an engine or device as you wish. An engine or a device you use. It is impossible to construct an device or engine operating in a cycle. Andre
100%.
Cycle andre repeat aganta process. Operating in a cycle produces work. Operating in a cycle produces work by exchanging heat with the single heat source or reservoir ಅಂದ್ರೆ ಇದಲ್ಲ ಲೇಕ್ ಅಲ್ಲ, ಹೀಟ್ ರಿಸರ್ವರ್ ಅಂದ್ರೆ ಗೊತ್ತಾ? ರಿಸರ್ವರ್ ಹೀಟ್ ಅಂದ್ರೆ ಎಷ್ಟು ಹೀಟ್ ತಗೋ ಈ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಆಗಲ್ಲ. ಸೋರ್ಸ್ ಅಂದ್ರೆ ಬಟ್ ಸಿಂಪಲ್ ಸೋರ್ಸ್. ರಿಸರ್ವ್ ಥರ್ಮಲ್ ರಿಸರ್ವರ್ ಅಂದ್ರೆ ಯು ಟೇಕ್ ಎನ್ ನಂಬರ್ ಆಫ್ ಹೀಟ್. ಸಮುದ್ರ ಐತೆ, ಒಂದು ಬೈಟ್ ನೀರು ತಗೋರಿ, ಏನ್ ನೀರು ಕಮ್ಮಿ ಆಗ್ತಾವ? ಒಂದು ಬ್ಯಾರಲ್ ತಗೋರಿ, ಕಮ್ಮಿ ಆಗ್ತಾವ? ಇಲ್ಲ. ಸೊ ಜಸ್ಟ್ ಲೈಕ್ ದಟ್. ಸೊ ಇಟ್ ಹ್ಯೂಜ್ ಅಮೌಂಟ್ ಆಫ್ ಪೊಟೆನ್ಷಿಯಲ್ ಆಫ್ ಹೀಟ್. Okay, it won't reduce even if you take heat. That's why it's called thermal reservoir. Source and sink, same thing. Source and change agila, sink and change agila. But even we drag, we take heat and we put, we add heat in sink. Clear?
Yes.
Note of it. KP statement. We go. The last topic is called classier statement. Classier statement ಅಂದ್ರೆ ಏನು? Is clear na? No more doubt here?
No, sir.
KP statement, no doubt.
No, sir.
Okay. Okay, next, classier statement. ಇವ್ರಿಗೆ ಕೆಲಸ ಇಲ್ಲ ಹೋಗ್ಸಿಲ್ಲ, ಬರೀ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕುಂದಿತ್ತು ನಮ್ಮ ಜೀವಿತ. ಬಟ್ ಅದು ಗೊತ್ತಿರ್ತದ. ಬಟ್ ಸುಮ್ಮನೆ ನ್ಯೂಟನ್ ಯಾರು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಈಗ ಚಾಕ್ಲೇಟ್ ಸ್ಕ್ಯಾನ್ ಊಟ ಬರ್ತದ, ಎಲ್ಲರೂ ಗೊತ್ತಿರ್ತದೆ. ಬಟ್ ಇದು ಎಕ್ಸ್ಪ್ಲೈನ್ ಇನ್ ಡೈರೆಕ್ಟ್ ಇನ್ ಬ್ಯೂಟಿಫುಲ್ ಮ್ಯಾನರ್, ಸೊ ಎವ್ರಿಯನ್ ಕ್ಯಾನ್ ಅಕ್ಸೆಪ್ಟ್ ಹಂಗೆ ಹೇಳ್ತಾರೆ. ಇದನ್ನ ನಿಮ್ಮ ಮಮ್ಮಿಗೆ ಹೇಳಿದ್ರು, ಮಮ್ಮಿ ನ್ಯೂಟನ್ ಸೆಕೆಂಡ್ ನ್ಯೂಟನ್ ಫಸ್ಟ್ ಹೇಳ್ದ, ಯಾರು ಮುಂದೆ ದುಃಖಿಸಿದ್ರೆ ಮುಂದೋಗ್ತಾರದು, ಇಲ್ಲ ಹೋಗಿಲ್ಲ. ನಿಮ್ಮ ಮಮ್ಮಿಗೆ ಹೇಳ್ರಿ, ಮಮ್ಮಿ ಅಂತ ಕೇಳೋರು, ಯಾವಾಗ ಏನು ಓದ್ತಿದ್ದೆ ಅವ್ರು ಇಂಥ ಪಾಠ ಕಲ್ಸೋದು ಕೇಳ್ತಾರ. ಮಮ್ಮಿಗೆ ಬೈದ ಬಿಡ್ತಾರ, ಇಂಥ ಪಾಠ ಹೇಳ್ತಾರೆ ಸ್ಕೂಲ್ ನಿಮ್ಗೆ ಸೈನ್ಸ್ ಇದೆ, ಇಂಗ್ಲೀಷ್ ಇದೆ. ನಾನು ಓದಿ ಫಸ್ಟ್ ಟೈಮ್ ಬರ್ತಿದ್ರು, ನಾನು ಓದಿದ್ದೀಗ ನಿಂಗೆ ಫಸ್ಟ್ ಟೈಮ್ ಬರ್ತಿದ್ರು. ಸಿಂಪಲ್ ಥಿಂಗ್ಸ್ ಅವು ನಮ್ಗೆ, ಬಟ್ ವಿ ಕ್ಯಾನ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಪ್ರಾಪರ್ಲಿ, ವಿ ಕ್ಯಾನ್ ಪ್ರೆಸೆಂಟ್. ದಟ್ಸ್ ವೈ ಮೆನಿ ಫೇಲ್. ಎಷ್ಟು ಸಿಂಪಲ್ ರೀ ಗ್ರಾಡ್ಯುಯೇಷನ್ ಆಗ ನ್ಯೂಟ್ರಲ್ ಗ್ರಾಡ್ಯುಯೇಷನ್ ಸಿಂಪಲ್ ಇತ್ತು. ಏನೇ ಮ್ಯಾಲೆ ಹೋಗಿ ವಾಪಸ್ ಬರ್ತೈತೆ. ಅದನ್ನ ನೆನ್ಪು ಮಾಡಾಕ, ಅದನ್ನ ಫಾರ್ಮುಲಾ ಮಾಡಾಕ ಕ್ಯಾಡಿ ಓದಿ ಇದು ಮಾಡಿರ್ತದೆ. ಜಿಗೂ 9.8 ಅದೇ ಎಕ್ಸಾಂಪಲ್ ನೆನ್ಪು ಬರಂಗಿಲ್ಲ. ಜಿ ವ್ಯಾಲ್ಯೂ ಕಾರ್ಡ್ ರಿಮೆಂಬರ್ ನಮ್ಗೆ ನೆನಪೇ ಆಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಅಷ್ಟು ನಾವು ಅದನ್ನ ಅಷ್ಟು ಕಂಪ್ಲೀಟ್ ಮಾಡ್ಕೊಡ್ತೀವಿ. ಸಿಂಪಲ್ ಇರ್ತದೆ. ಜಿ ಐ ಟೋಲ್ಡ್ ಗ್ರಾಡ್ಯುಯೇಷನ್ ವಾಸ್ ಈಕ್ವಲ್ ಟು ಜಿ m1 m2 by d ಸ್ಕ್ವೇರ್. ವೆರಿ ಸಿಂಪಲ್ ಇತ್ತು. ಜಿ ಗೊತ್ತಿರಬೇಕು, m1 ಮಾಸ್ ಗೊತ್ತಿರಬೇಕು, ಡಿಸ್ಟೆನ್ಸ್ ಗೊತ್ತಿರಬೇಕು, ಮುಗಿತು. ಸ್ಕ್ವೇರ್ ಡಿಸ್ಟೆನ್ಸ್ ಹೀಗೆ ಗ್ರಾಡ್ಯುಯೇಷನ್ ಫೋರ್ಸ್. ನಾವು ಅದನ್ನ ಎಷ್ಟು ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತೀವಿ, ಈ ಫಾರ್ಮ್ ಹೆಂಗೆ ನೆನ್ಪಿಡೋದು, ಏನು ಮಾಡೋದು, ಅದನ್ನ ಟ್ರಿಕ್ಸ್ ಮಾಡಿ ಚೀಟ್ ಕೋಡ್ ಮಾಡಿ ನೆನ್ಪಿಡ್ತೀವಿ ನಾವು. ವೆರಿ ಸಿಂಪಲ್ ಅದು. ಈಗ ಕೆಪಿ ಸಿಂಪಲ್ ಐತಿ, ಹೌದಾ? PMF ಹೇಳಿದ್ರೆ ನೋ ಇಂಜೆಸ್ 100% ಎಫಿಷಿಯಂಟ್, ದಟ್ಸ್ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ, ಹೌದಿಲ್ಲ? ಸೊ ದಟ್ಸ್ ವೈ ವಿ ಮೂವ್ ಟುವರ್ಡ್ಸ್ ಪರ್ಫೆಕ್ಷನ್. ಅದಕ್ಕೆ ಕ್ಲಾಸಸ್ ಇವು ಹೇಳ್ತಾನ, ವೆರಿ ಸಿಂಪಲ್ ಹೇಳ್ತಾನೆ. ಇವ್ ನೋಡಿ ನಗು ಬರ್ತದೆ, ಸ್ಟೇಟ್ಮೆಂಟ್ ನೋಡಿ ಫುಲ್ ನಗು ಬರ್ತದೆ. ಏನಂತ, ಓಕೆ, ಇಟ್ ಇಸ್ ಇಂಪಾಸಿಬಲ್ ಟು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆನ್ ಡಿವೈಸ್ ಆಪರೇಟಿಂಗ್ ಇನ್ ಅ ಸೈಕಲ್ which transfers heat from lower temperature sink to source ಅಂತ ಇಷ್ಟೇ. Very good question, but first is adding work. ಇಲ್ಲಿ ವರ್ಕ್ ಐತಿ. ಅವ ಏನಂತಾನ, ಇಟ್ಸ್ ಇಂಪಾಸಿಬಲ್ ಟು ಕನ್ಸ್ಟ್ರಕ್ಟ್ any heat engine in a device which operating in a cycle. ಸೈಕಲ್ ಅಂದ್ರೆ ಗೊತ್ತಾ? thermodynamics cycle ಹೆಂಗ ಅಂದ್ರೆ, the cycle means it come back to initial position. Any work you do, it come back to initial position. A petrol source ಗಾಡಿ ನಾವು when you burn petrol, it goes suction, compression ಎಲ್ಲ ಸ್ಟ್ರೋಕ್ ಆಗ್ತಾವ, ಮತ್ತೆ again it go back to original position. Cycle, everything happens in cycle. This is called cycle. Initial point ಮತ್ತೆ ವಾಪಸ್ ಬಂದೇ ಬರುತ್ತೆ, not process, I'm dealing with the cycle. So any device operating in cycle, okay, it is impossible to construct a device which operates in cycle transfers heat from low temperature sink to high temperature source without adding work. Possible?
No, sir.
ಇಲ್ಲ. If add work, ಜಿಕ್ಕೊಂಡ್ ಕೆಲಸ ಮಾಡ್ತದೆ, ಕೆಲಸ ಮಾಡೋದು, ಇಷ್ಟ ಫ್ರೀಸ್ ಜಾಸ್ತಿ ಮಾಡಿ ಐಸ್ ಮಾಡೋದು. ಏನ್ ಹೇಳಿದ್ರೆ ರೆಡಿ, ಸಿಂಪಲ್ ಇಸ್ಕೊಂಡು ರೆಫ್ರಿಜರೇಟರ್. ನೀವು ವರ್ಕ್ ಕೊಡಬೇಡ, ಏನಂತದ ಅಲ್ಮಾರ. ಆರಾಮ್ ಕೀಪ್ ಇನ್ ಕಬೋರ್ಡ್ ಎಲ್ಲ ಇಡ್ಬೋದು, ಮನೆ ಬುಕ್ಸ್ ಇಡ್ಬೋದು, ಪೆನ್ ಇಡ್ಬೋದು, ನಿನ್ ಕಂಪಾಸ್ ಇಡ್ಬೋದು, ಎಲ್ಲ ಇಡ್ಬೋದು. ಕನ್ನಡದ ಎಲ್ಲ ತೆಗೀರಿ, ಬಟನ್ ಹಾಕ್ರಿ, ಫ್ರಿಜ್ ಅದು ಅಷ್ಟು. ಇದು ಕ್ಲಾಸಿಕ್. ಇಷ್ಟು ಕೂಡ ಅನ್ಸುತ್ತೆ ನಿಮ್ಗೆ ಎಷ್ಟು ಚೀಪ್ ಐತಲ್ಲ, ಏನಿದ್ರೆ ಸಿಂಪಲ್ ಐತೆ ಅದು. ಹಾ ಅಷ್ಟೇ. ಕ್ಲಾಸ್ ವೆರಿ ಬಿಕಾಸ್ ಇಟ್ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ನಥಿಂಗ್. ಐ ಡೋಂಟ್ ನೋ ಹೌ ಇಟ್ ಟೋಲ್ಡ್ ಇನ್ ಕಾಲೇಜ್, ಬಟ್ ಇದನ್ನ ಎಷ್ಟು ಡಿಫಿಕಲ್ಟ್ ಮಾಡಿರ್ತಾರೆ ಅಂದ್ರೆ ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಹಂಗೈತೆ ಹಿಂಗೈತೆ, ಇಟ್ಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ರಿಮೆಂಬರ್ಶಿಪ್. ಮಗ್ಗಪ್ ಅಂತ ಹೇಳ್ತಿರ್ತಾರೆ. ನೀವು ಮಗ್ಗಪ್ ಮಾಡಕ್ಕೆ ಹೇಳ್ತಿದ್ದೀರಿ, ನೀನು ಬ್ಯಾಟ್ ಮಾಡಿರ್ತಾರೆ. ಅಗ್ರಿ ಸಿಂಪಲ್ ಇದ್ರೆ ಸಿಂಪಲ್ ಎಲ್ಲಿ ನೋಡಿಲ್ಲ ಇದ್ರ ಜೀವನದಲ್ಲಿ. ಈ ಡೈಗ್ರಾಮ್ ಅರ್ಥ ಆಗ್ಬಿಡುತ್ತೆ. ಓಕೆ, ಹೆಂಗ್ ಗೊತ್ತೈತೆ ಮೇಲೆ ಹೆಂಗ್ ಗೊತ್ತೈತಿ. ಇದು ಲೋ ಟೆಂಪರೇಚರ್ ವಿನೋ. ಓಕೆ, T1 ತಗೋ, ಇದು T2 ತಗೋ. ಏನದ ವಿನೋ T1 ಇಸ್ ಗ್ರೇಟರ್ T2 ಎಲ್ಲ ಗೊತ್ತೈತಿ. ಈಗ ಉಲ್ಟ್ ಮಾಡೋ, ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡೋ. ಹೆಂಗ್ ಮಾಡೋದು? ನಿಮ್ಮ ಮನೆಗೆ ನೀವು ಯಾರು ಕೇಳ್ತಾರೆ, ನಿಮ್ಮ ಅಜ್ಜಿ ಕೇಳಿ, ನಿಮ್ಮ ತಮ್ಮ ಕೇಳಿ ಹೇಳ್ತಾರಲ್ಲ. ಆಗ ಏನಾಗಿ ಫ್ರಿಜ್ ಕೆಲಸ ಮಾಡಿದ್ರೆ ಫ್ರಿಜ್ಜೇ ಬೇಕು. ನಾವೆಲ್ಲ ಅಡಿಗೆ ಸಾಮಾನು ತಂದು ಇಡಬೇಕು. ಫ್ರಿಜ್ ಕೆಲಸ ಮಾಡ್ತೀವಿ, ಕರೆಂಟ್ ಕೆಲಸ ಮಾಡ್ತೀವಿ, ಮುಗೀತು. ಜಸ್ಟ್ ಕಾಮನ್ ಸೆನ್ಸ್. ನೀವು ಫುಲ್ ಯೋಚನೆ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ನೀವು ಕ್ಲಾಸ್ ಚೆಕ್ ಮಾಡ್ರಿ. ಕರೆಕ್ಟಾ? ಸೆವಾ ಟ್ರೀಟ್ಮೆಂಟ್ ಕೊಟ್ಟಲ್ಲ ಬಿಫೋರ್ ಇನ್ವೆಂಟಿಂಗ್ ಫ್ರಿಜ್. ಆ ಫ್ರಿಜ್ ಎಲ್ಲ ಫ್ರಿಜ್ ಫಸ್ಟ್ ಟೈಮ್ ಮನೆಯಿಂದ ನೋಡೋದು. ವಾವ್, ನಮ್ಮ ಫ್ರಿಜ್ ತಂದು ತೆಗೆದು ನೋಡಿದ್ರೆ ತಣ್ಣೀರು ಕುಡಿದೋದು. ಹೌದಿಲ್ಲ? ಸೊ ಫಸ್ಟ್ ಫ್ರಿಜ್. ನೀವು ಫಸ್ಟ್ ಫ್ರಿಜ್ ಮನೆಗೆ ನಾನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಬಂದರೆ ಲೈಟ್ ಟೈಮ್ ಬರ್ತದೆ ಅದ್ರಾಗ. ನಾನು ಎಷ್ಟು ಹೆಚ್ಚು ಮಾಡಿದ್ರೆ ಲೈಟ್ ಟೈಮ್ ಮನೆ ನಾನು ಬಟನ್ ಹಾಕಿ ಅಲ್ಲಿ ಹೆಂಗೆ ಬರ್ತೈತಿ. ಎಷ್ಟು ಎಲ್ಲ ಹುಡುಗಿನ ಫ್ರಿಜ್ಜಿಗೆ ಲೈಟ್ ಹಾಕ್ತಾರೆ. ಯಾರು ಲೈಟ್ ಹಾಕ್ತಾರೆ, ಯಾರು ಇದ್ದಾರೆ ಒಳಗೇನು ಹುಡುಗರು ಸಾಕೋದು. ನಾನು ಎಲ್ಲ ಕಂಪ್ನಿ ಲೈಟ್ ಹಾಕ್ತಾರೆ ಅಂತ ಮನೆಗೆ. ಅವ್ರ ಕಂಪ್ನಿ ಗೊತ್ತದ, ಮಿಸ್ಸರ್ ಗೊತ್ತದ ಅವ್ರಿಗೆ, ಅವ್ರು ಲೈಟ್ ಹಾಕ್ತಾರೆ ಅಂತ ಫ್ರಿಜ್ನಾಗ. ಕಂಪ್ನಿಗೆ ಅವ್ರಿಗೆ ರಾತ್ರಿ 2 ಗಂಟೆ ಆಯ್ತು ನೋಡ್ತಾರೆ. ನಾನು ಕಂಪ್ನಿ ಅಂತ ನೋಡೋವಂತ ರಾತ್ರಿ 2 ಗಂಟೆ ಆಯ್ತು ನೋಡೋಕೆ ಲೈಟ್ ಬರ್ತೈತಿ. ಅಂದ್ರೆ ಕಂಪ್ನಿ 2 ಗಂಟೆ ಇಟ್ಕೊಂತಾರ. ಅದು ನಮ್ಮ ಮನೆ ಫ್ರಿಜ್ ಸಲಹೆಗಳು ಇಟ್ಕೊಂತಾರ ಅಂತ ಅರ್ಥ ಆಯ್ತು. ಇವ್ರು ಬಾಯ್ದು ಲೈಟ್ ಹಾಕೋದಕ್ಕೆ. ಆಮೇಲೆ ಗೊತ್ತಾಯ್ತು, ಅಲ್ಲಿ ಡೋರ್ ಕ್ಲೋಸ್ ಮಾಡಿದ್ರೆ ಸ್ಮಾಲ್ ಬಡ ಇರ್ತೈತಿ, ಅದು ಕ್ಲೋಸ್ ಆಗ್ತದೆ ಅಷ್ಟೇ. ಅದಕ್ಕೆ ಮ್ಯಾಜಿಕ್ ಐತೆ, ಸಿಂಪಲ್ ಐತೆ, ಬಟ್ ಯು ಫೀಲ್ ಇಟ್ಸ್ ಮ್ಯಾಜಿಕ್. ಇಟ್ಸ್ ಇಂಪಾಸಿಬಲ್. Possible and we have work. It is impossible to construct and devise. Same statement. Other exception not understand. It is impossible to construct a device operating in a cycle. Transfers heat from. It is impossible to construct a device operating in a cycle, transfers heat from low temperature sink to high temperature source. Low temperature sink to high temperature source without adding work. No work we add. Without adding work. Done? And simple. This statement can be exact opposite agata. Just simple without tegedu with madbidu. Possible. Clear? Draw then bend word up.
What is the significance of second law of thermodynamics?
Significance of second thermodynamics. It tells the direction of heat transfer, direction of work transfer, how it happens. Illa direction antiradhu this is direction. Reverse ಮಾಡಕ್ಕಿಲ್ಲ, ಬಟ್ ವರ್ಕ್ ಕೊಡ್ರಿ ಮಾಡ್ತದೆ ಕೆಲಸ. Even same thing for KP statement also. Hello plan. On same ಮಾಡ್ತಾನೆ. Right? Source sync ಕೊಟ್ಬಿಟ್ಟು ಕೆಲಸ ಮಾಡ್ತಾನೆ ನಾನು. Direction ಬೇಕಲ್ಲ? It's the same these directions. We give both magnitude and direction. First one gives only magnitude, no direction. The second one gives both magnitude as well as direction. ಮತ್ತೆ vector ತರ ಇಲ್ಲ ಅದನ್ನ. Don't call second law as vector. We have both of them, it can come vector because they have both magnitude and direction. Can you call it vector? No. Second law is not a vector. It's just a law.